So I'm here to talk about RxJS. It is the JavaScript version of a library called ReactiveX, and there's a particular pattern. There's a lot going on with ReactiveX, so I'm going to take it from the path of an autocomplete, which suits really well to the magical powers here. I'm going to go through just a slideshow, but at the bottom, and this will be on every single slide, I'm going to be talking about how to make an autocomplete component in vanilla.js, but I do have code for React. And for the super cool folks out there who use Recompose, they do have a really cool way of mapping observables to your props, which will mean nothing until you know something about about RxJS. So without further ado, the task that we're going to tackle here is an autocomplete. And a good way to start a problem is to phrase the problem. And so what is an autocomplete function? So it's basically, as the user types, requests are made to an API. Usually there are autocompletes that have an inbuilt list, but we're talking about one that's going to an external API and returns all the possible or suggested results. Now the naive solution to this would be we have our input bar, and just every single time there's an input event, if you're in React, they would be an on-change event, that we would just send a new request to our database for every single result. And you can do this, and it may look like it works at first, but there's a number of problems with this. So the issues are, first of all, yeah, you guys thought it would be boring, but I put GIFs in here just for you. So people type really fast. So the average typer does 30 words per minute, and I think because we're in the tech community, we know people who can do well over 100 words per minute. And just pretend that this bunny is our server, and those pancakes are all the requests that we're sending on an on-change event. It can overload the server, and you won't get results back, and it will make your input field laggy. Second problem, redundant requests. So let's say your server receives all those requests, and let's use the example of someone's on an e-commerce site and they're typing something like mittens. They know what they're looking for. They're looking for mittens. So by the time they type M-I-T-T, the results for M, the results for I, the results for T are all excessive at that point. Or even think too, let's say they're looking for mittens and they write M-I-T-T-A, it's a typo, and then they go back one space. So you send out the request for M-I-T-T-A, and you go back to M-I-T-T, and you have done 2 requests and in exchange gotten no new information. And this is probably the most important issue with just doing the naive solution, which is when you send requests to an API, there is no guarantee that you're going to get them back in the same order. In fact, it's very possible that they won't resolve in the order that you send them, because if you think about a database, let's say you're trying to match results to parts of your database, and let's use the example of the e-commerce site again. You're looking for mittens. You're going to have more results for MI than you are for MITT, and that makes it, and it's when you have more results in a database, it actually is a slower process for them to get it. So it might resolve your MITT request before it resolves the MIT, and then it'll resolve first. You'll get those things, and you'll set the result to your resultant list, and then your other results for your previous request will amble in, and now they're out of sync. So how do we solve these problems? RxJS, observables. So this is just a wall of text, but basically an observable observes a stream of events, or excuse me, an observer observes a stream of events received over the time. And it's that actual stream that we call an observable. This is just jargon, but basically we use an observer to create an observable, and then we can configure that observable, that stream of events, to emit a corresponding stream based off of certain parameters that we give it, or what we're going to call operators. So In this case, Ralph is our observable, and there's a stream of inputs coming in over time. We have pancakes, we have milkshakes, and part of what he does is he takes those streams of pancakes and milkshakes and either passes it to Pink Bunny or Blue Bunny. And now we're going to configure our observable. So to start out with, to make an observable, and in vanilla.js, to make it really easy in the RxJS library, and I should mention for a second here that ReactiveX is not the only observable library out there, but it's extremely popular, particularly since someone's going to be talking about Angular. Angular relies heavily on RxJS, and in fact, Google contributes in large amounts to the project. So I would say it's certainly one of the more popular libraries out there, and it's worth learning for that reason. And here, as part of the library, if you're using just no framework, vanilla.js, they have a really pre-configured observer called fromEvent that you can, the first argument that it takes is a DOM element. In this case, I'm calling it search box. That's going to be an input field where we have our input that the users are going to type in, and then the kind of event that it's listening for. And so it's going to make a stream of those event objects over time. And the way that we configure the outputting stream is that we do .pipe. Now, this changed since in April, RxJS 6 came out. In RxJS 5, all of our operators would have been methods on our observable. Every single observable had them as methods. We're configuring this with something called .pipe, which if you're a functional programmer should make you very happy, as opposed to having chaining for our observable. So hopefully that will be more clear as we get through the code. So the first way that we're going to configure our observable, as all of these input events are coming in as a stream, this is the one that's going to be the biggest gatekeeper from all those excessive responses. So what debounce does is that it's actually debounce time in RxJS 6. This is just a picture that I found. Very popular with RxJS is marble diagrams, which is that on the top is the incoming stream and then the corresponding outgoing stream. So if we look at debounce and all of the requests that are going in, it takes as its only parameter an amount of time in milliseconds. So if you say, I want debounce time to last, let's say we configure it for 250 milliseconds. If when it gets the first response, it doesn't emit it until 250 milliseconds have passed. And then it says, what was the most recent request within that debounce designated amount of time? And the reason why this is important for an autocomplete is it's got the effect of being like the user just stopped typing. So let's say they're putting in all these input events in their input event field. It then becomes, the event won't register. It won't move into the next operator in our pipe unless there are no more incoming events for at least that designated amount of time. So the way it looks like in code, we have our observable, we have our .pipe, and we put debounce time, 250 milliseconds. Now another thing is this stream is actually, the way it's configured from event, is a stream of event objects. And if anyone has ever console logged an event object before, you know that there's a lot of information in there. And usually what we're interested in is event.target.value. So inside of our observable, what we can do with every single event that goes in, we can do a map function. And it doesn't have to be this, but the way I'm using .map in order to complete our observable sandwich is to, as these event objects come in, it's going, and we pipe in the event objects based off of debounce time, we then pull out or return event.target.value. So that's our next part of our pipe. The third part, again, these pictures coming a lot from RxJS 5, so this is going to be distinct until changed. And it doesn't take any arguments, but basically, if you look at the marble diagram, if it's the same thing, think of the example of how I said someone might type in MITT-A, and then they backspace to MITT. If it happened within that debounce time, it would be the same request. And so if we say distinct until change, it's not going to set out a new request because it hasn't changed from the previous response that it sent. So, or the previous outputted request. So distinct until change, very useful operator. And then, yes? Oh. This one. In distinct you are, and that's a really good catch because I did not realize in this marble diagram, because one had happened earlier in the event stream, that it isn't doing it. I have to look at the documentation. No, I know because I've done examples. If you use distinct until changed and not distinct, it will only cancel the operation if it was the previously inputted. I would want to check the documentation on that, but if you use distinct until change, this marble diagram is incorrect. No, this diagram is supposed to just represent the actual operator itself and not necessarily the one in our sandwich. So I think it's because they're actually two different operators, and so I didn't catch that when I was making this presentation, that this is not distinct until changed. This is distinct. Yeah. So I appreciate you catching that, though, because that is 100% correct. Distinct is different from distinct until changed. Okay. And then filter. So if you think about relevant queries to our autocomplete, if the query is maybe 1 or 2 in length, and we can configure this however we want, the results would probably be meaningless to the user who's trying to find relevant content. So what we can do is take query strings that are, let's say, less than 2 and not pass them further into our pipe. Because what we're working towards is eventually we're going to limit our stream to only a certain amount of queries. And when we finally send it off, we want it to be relevant to the user. So we can use filter to only pass in things that, for example, if the previous query that's been passed up until this point has at least a length of 2. So I did that in my example here. And you'll notice that as it accepts the thing that's being passed from the other operators, in this case, the actual query string, I did a OR statement to include, I only want things that are greater than 2 in length, because otherwise I don't think that the results are going to be relevant to the user, or if it's 0. And the reason why I want to pass in the queries that are 0 is so that it will remove all of the results, basically do an empty search that will clear the input field. If you look at Google, they actually keep, if you backspace, let's say you type in a search and you backspace until the input field is empty, they choose to actually keep the results there. But this is how this particular one is configured. And so this is going to be the piece de resistance of our pipe sandwich about, okay, all of the queries that have survived the gauntlet of all the operators we've had, making sure that they're distinct until changed, making sure that they're at least a length of 2, making sure that it is only the latest ones in that period of debounce. SwitchMap, every single time a request is made, it takes in whatever is passed to it, and it returns, the callback returns an observable. And so SwitchMap subscribes to that inner observable, and I'll get to the code in a second to break this down a little bit more. It subscribes to the inner observable, and you can actually make observables from promises. So basically, you return an observable of the promise of the actual request that you're making, and subscribe to the result, which would be the resolved promise. But if a new query comes in before it resolves that particular promise, it abandons whatever the previous inner observable was and subscribes to the new one. So I do just want to pull up the code here to kind of explain that. So let's say everything that survived, the value of our query, gets passed into switchMap. Let's say it's MITT in our example. The first thing I do is, in this case, I do a ternary to check if it's a length of 0, if it's an empty string or not. Because if it's an empty string, you can see on the second part, I just resolve a promise to an empty array. The reason why it does items is that if you go to the code, it's actually a GitHub user search. And so that's how they return the results. But before we even talk about, well, I already talked about the ternary. But on the left-hand side, basically, if we have a valid query that got passed through, it has at least a length of 2, it's distinct until changed, it was the latest in our debounce time. From is an observer that makes an observable from promises. And it's going to, when that observable resolves, it's going to pass that through into our emitted data stream, which is the whole goal of what we're trying to do here. But if a new value comes, and this is just repeating it because it's the most important concept, if a new value comes down the line before that observable has emitted the result of its promise, it's going to switch the inner observable to whatever the latest query was, and that way you guarantee that you will never get out of sync results because it abandons it the moment you get a later result. So we now have our .pipe completely filled in. It's emitting an event stream based off of all of the parameters that we've given to it. And now we want to do something with the results, namely the promises that are going to be returned, probably from our database or whatever external API you're using. And so the way that we get the resultant data and then do something with it is called subscribe. It's going to take those events and we basically give it a callback. So in my example, the first thing I do, I have a results field near my input thing right below it called results. That's the DOM element. It's a UL. First thing I do is I clear the UL. I originally had an inner.html equals an empty string, but I knew that a lot of people from Visual Class was going to be here, and that is bad practice. So I did the while loop to remove all of the previous results from our UL. And then I map every single result to an LI that I create. But basically the data that's being passed through, because we use the switchMap, is our resolved promises of all of our valid queries. And then we take each of those, we take that array that gets returned to us, and we're going to map the result to it. And so at the end of all of that, we get something that looks like this. And these are GitHub usernames using the GitHub API. So you do all that, you did it. Woo. Now, I have a more detailed description because for anyone that's ever spoken before, this is very nerve-wracking. So I wrote a Medium article that basically maps everything I just talked about, uses really good examples. Well, I mean, it has lots of examples, and it goes line by line through your code of how to do it. So that's a little link to the Medium article. So I don't know how much, do I have a couple minutes for questions, or is that, yeah. Does anyone have any questions? Inner.html, or it's because a lot of security software can be looking for inner.html, because if you, for example, had an input field that set the inner HTML, that would make you open to a script injection attack. So it's not so much that if you're setting it to an empty string that something bad can happen, but I do believe there are some kind of softwares and security softwares that look for inner HTML. At least that's what someone told me, and I'm sticking to it. Any other questions? Those are GitHub repos, and in each of them, the vanilla JS, that would be using the from event. There's a couple extra things. I realized as I was putting this together that there was no way that I was going to be able to do vanilla JS and React in 15 minutes. So, but there's some special things about mapping the results just like we did .subscribe to create our li elements, you can actually map the data that survives to props in your React components. I know Angular uses observables more. So those are going to be libraries, those are the exact same example, except in the React framework. So switchMap returns in, I want to say yes and then say but. So switchMap returns an observable, so you have to make sure that the thing that you're actually returning is an observable. And then when that observable emits something, namely if you're making an observable from a promise, effectively the thing that it's emitting is the resolved promise. So yes. So if we look at subscribe, actually, you'll notice that input was the configured thing from event is actually the observable that we're subscribing to, and it happens to be configured with .pipe. So whatever comes out the other end of the from event observable is what .subscribe picks up as and uses, and that's what you can use in your callback. Right, so it goes in order. So it's basically, if you think about how it used to be dot chaining, it's basically going to resolve the thing that's higher up in the pipe first and resolve and resolve and resolve. So in this case it is, but for example, if you wanted to have a dot map after because the results that you returned, you were only interested in particular information, you could keep configuring your dot pipe to whittle it down even more. So basically, when a value comes through, what this callback does is it returns an observable. And so basically switchMap subscribes to that inner observable, and it only subscribes to one, and that's the latest one. So anytime a new value gets passed to switchMap, so long as you're returning another observable, it's not so much like on request, it's that it only subscribes to one, and it's only going to subscribe to the latest observable that you return. All right, so I know you are all experts in observables now, and we use them all the time, so thank you. Oh. Well, it's mainly because I wanted to have an autocomplete function on an application I was working on, and they're so ubiquitous across web applications that it seemed like, this must be something that people have a solution to. And actually, I have to give a lot of credit to Jonathan, who's an instructor at Digital Crafts, for being like, you should learn something called observables. And so I had graduated at that point, and so I just read documentation for a week or two in order to bring you this lovely presentation. And if I can do a moment of self-promotion too, I am a TA at Digital Crafts right now, but that's going to end in about a month, so if anyone is looking for a developer, I would like to be one. So, thank you guys. And,